All right, so we're still in section 2 of chapter 5, and what we're going to do is we spent quite a number of time trying to walk through the steps of how to solve a system of equations when you're dealing with, well, in this case, it was first order differential equations in our system. And we saw that it was a culmination of some of the techniques that we had learned back in chapter 4. What I want to do is I want to offer a semi-shortcut. What we're going to do is this still is quite demanding, and I still will probably need 2 videos to finish this problem. But the idea of if you have your system in differential operator form, so now you'll really this little technique is set up for if you have it in differential operator form. You'll now get to see more of the value of why the differential operator notation is helpful. So again, what we have is this L1, L2, L3, L4. These are the D operations, the D notation for differential operators, D of T, D of T. So the idea for this problem is going to be first to get it in operator form. And then for part B, which is all we'll get through for this particular video, is here's a quick way to eliminate either y or eliminate x. Okay? So notice that I'm going to come back to this, but notice that we have two little equations that are set up perfectly using that operator notation that automatically can eliminate y or x for us. Now, that just saves us time at the beginning. We still have to go through, we still won't know what y is or what x is. We've just eliminated one of them. So then we still have to go through our method of undetermined coefficients to actually figure out what y is. But in that case, let me kind of walk you through this example. All right. So now notice in this particular case, we actually do have these are a system of 2 equations, but this is actually a second order differential equation and a first order differential equation. So that first step is to get it in differential operator form. So I won't go through that with you. I do have to start to expedite the process a little bit. So let's just assume that you can get step 1 done. Now, what we're going to do is we're going to go through and we're going to label. If you recall, we had L sub 1, L sub 1, L sub 2, and so forth. So in this case, L sub 1 would be the d squared minus 1, and L sub 2 would be d plus 1. L sub 3 would be d minus 1. L sub 4 would just be d. And f sub 1 would be negative 1, and f sub 2 would be t squared. Okay? So now, once you have all of this written out, you would have to choose, do you want to eliminate x or do you want to eliminate y? Now, we're going to choose the elimination of y. Not that it matters a whole lot, just for the sheer fact that, well, you'll see as the problem unfolds. So what I'm going to do now is, this is my setup if I want to eliminate y. So I'm going to go and plug in L1, L2, L3, L4, everything in the right spot. So this is going to look like the following. Then we have d plus 1, d minus 1. And you're welcome to put of x if you'd like. But you'll see where I'm going with this in just a second. So now L sub 4 would be d. That would be negative 1 minus d plus 1 of t squared. Okay. So at this stage, what we're going to do is we need to go ahead and work out what this little bit of this basically multiplication of this operator would yield. And so I'm going to go ahead and do that on the next page here. All right, so let's go ahead and walk through this. So let's start with the following. And again, I offer this without much explanation because I've already gone through how you approach this. So that would end up being minus d plus d and minus 1, which is just d squared minus 1. All right, and then of course at this stage, when you take your derivative of -1, you get 0. And then when you take, now we would have d of, well, the derivative of t squared would be 2t. Derivative of, or then 1 plus t squared would just, 1 distributed to t squared would just be t squared, yeah. Okay, so let's now rewrite, I'm going to go ahead and rewrite this form here, but now I actually have everything simplified a little bit more, okay? So it ends up looking like this. So you have t, it's just basically your y triple prime minus d. That would be minus, let me use some grouping symbols here. That would be d squared minus 1. And that's going to be equal to, well, that was 0 plus, in this case actually 0 minus, yep, 0 minus, and again let me use my grouping symbols. So that's 2t plus t squared. Okay, so everything is in the right spot. What I'm going to do right now is get rid of the 0, change my signs here, go ahead and drop all these parentheses, change my signs, combine like terms, and go back and put it as a function of x. Okay, so it looks like this. We have d cubed minus d squared plus 1. All that is a function of x. That's equal to, that's going to be negative 2t minus t squared. Okay. So now, what I'm going to do is I'm going to go ahead and I'm going to copy and paste this part over to the next page, but I want to show you what this would also look like in y notation, right? So this is the same thing as having y triple prime. I'll go ahead and write it in order, minus y double prime minus y prime plus y. Actually, well, I haven't substituted yet, so let me not do that really quickly. I wanted to show you where we were going with this, but let me definitely not do that yet, because you're wondering where the x's go, and I know what you're talking about. All right, so let me go ahead and grab this, and let me paste this right here. Okay, so normally what you would do is, as you recall, you would have to have, don't worry about this up here just yet, okay, I'll get us there. But normally what you would have to have is the particular solution, and you would have to go into, you get your general solution, you have to go into auxiliary form, and then you would solve for r. I just want to show you really quickly how you can actually go from differential operator form. If you listen to me really quickly, you can actually go from differential operator form right to auxiliary form, and you'll be able to know exactly what your r values are. Okay, So let me go ahead and show you really quickly. See if I have enough room on the previous page. I do. So this is what all I'm doing right now is I just want to show you how you can basically group this up and factor it all out. Okay, so for example, you can place some arbitrary parentheses here and here. You can factor out a d squared here. That would leave you with a d minus a 1. All right, now looking at this this next portion here, I would also need a d minus 1. So if I factor out a negative 1, I would have a d minus 1. Okay, and now I can basically, this is factoring by grouping is what we're doing here. So now I can factor out a d minus 1. And what would be left would be d squared. If I factor out d minus 1, you have d squared minus 1. Okay, which is the same as, come over here, this is the same as d minus 1 times, now d squared minus 1 is just the difference of two squares, so that would be d minus 1 d plus 1. And now you can see how all of this goes to d minus 1 squared times d plus 1. Okay. Now, what I was attempting to show you is once you get it in this form here, you actually can get right to your auxiliary form and solve for your roots very quickly. So in this case, this is what it would look like in auxiliary form. So it would just simply be r minus 1 squared. Then you would have r plus 1. So what do we get? So what we get in this case is r is equal to 1, 1, and negative 1, right? We have a degree of 3. And now, let me now take these roots here. This r is equal to 1, 1, and negative 1. All right, we have basically a multiplicity of 2. All right, so let me write that. So if you have r is equal to 1, 1, and r is equal to negative 1. Okay, so if you recall that when you have, this is back to 4.3, so you either have two distinct roots, or you have two distinct real roots, or you have two distinct imaginary roots, or you have real but non-distinct roots, right? And in that case, you get an r value that pops up this twice. Okay, that's when you have a double root. So if you recall, this is the way that we had to approach this double root. Now again, if it's been a while, you might have to brush up on or look back at your notes, but this is the way we would what I'm underlining here, this double root, this is how you tackle this part right here. And then of course we have that single root, that non-double root as just negative 1 there. So all right, so let me now go ahead and place everything in its correct form. Okay, so in this case we have x of t is going to be equal to, this is just the general solution, it's going to be equal to c sub 1 e to the t plus c sub 2. Well, let me not, I will make this the negative 1, just like I have it above. So negative t. So I'm plugging in my r values. So that's c sub 2 t e to the positive t and that's going to be plus c sub 3 e to the positive t. Okay, so let me box this in, because what is this? This is just the general solution. Right, that's the general solution to the homogeneous part. So now I would need to, just like prior, I would have to look at my the right-hand side of my equation to find the particular solution for the non-homogeneous part. So I'm looking at this negative 2t minus t squared, and I'm trying to think of what form should y take. Well, I'm seeing the highest degree is a degree of 2, so we definitely are going to want some type of quadratic for y. All right. And now I need to go ahead and take my derivatives, just like prior. Ready? So that would be y prime is equal to 2at plus b. Y double prime is simply equal to 2a. And now, what I was trying to show you a second ago, how you can think of that, the differential back in y notation. Let me now show you where you would have to go with this. So really, the degree is 3. So you would need the y triple prime in a scenario like this. Okay, so let me now go ahead and bring back what I had just a second ago. So this would be the setup for looking at the right-hand side of the equation, negative 2t minus t squared. So this is going to be our setup. But then you know what happens. Now we actually have to plug it into something, right? So at this stage, I want to bring back in the y notation that I had that I had written and then I had erased. So if I write that d cubed minus d squared minus d plus 1, and I want to rewrite that back in the notation of y, right, or y of t, right? So then you can see that this would be y triple prime minus y double prime minus y prime plus y. And that's got to be equal to negative 2t minus t squared. Okay, so I think it now is as good of a time as any to take a break in this problem. When we come back, what you're going to see me do is plug in for y, y prime, y double prime, y triple prime, and then I'm going to try to figure out what a, b, and c have to be in order to make it equal negative 2 minus t squared, negative 2t minus t squared. So that's where we'll pick up when we come back.